The core mission at core, why we started Loki Robotics, and to be frank with you, why we got into robotics in the first place, is because we just think that human time is the most valuable capital we have as individuals, and we should strive as a humanity to do utmost best to free up as much of that important capital as we possibly can. The main interface of the data collection pipeline is the VR headset. Now, we arrived at the VR headset and the VR controllers because through iterations we found out that VR is actually one of the most intuitive ways how we can mimic our emotions that we do as humans and transfer that to a robot, right? How exactly are we positioned in space? Do I need to move my robot arm 1 meter further in? Am I already touching the surface? That wasn't intuitive at all.
Hi everyone, welcome back to the All Things XR podcast. In today's episode, I have Mix Ozols, CEO and co-founder of Loki Robotics. Hi Mix.
Hey, what's up? Happy to be here.
Thanks very much. So, Mix, can you tell a bit about yourself, your background, and how you originally started in the technology industry?
Yeah, so I guess the interest in technology comes long in my early days as a kid. Really been building lots of stuff in my garage back in the countryside in Latvia. Naturally, I think as a result, I gravitated towards a career in engineering. So I did my undergrad in aerospace engineering at TU Delft. And there I had the chance to actually build an autonomous race car as part of a Formula Student competition, which TLDR is like a small competition where you build an autonomous race car from scratch within 1 year with a bunch of motivated students, and then you race it. And two interesting things happened within that project. One is I figured out that though I love mechanical and aerospace engineering, working with composite materials, which is what I was doing at the time, is not fully my thing and doesn't really scratch the itch of engineering. But then COVID actually hit and the competition didn't go through. So what we did is we built basically a simulator, which is called Formula Student Driverless Simulator, which allowed autonomous systems with those race cars to race online, right? And there I realized, okay, the combination of software and hardware and robotics in particular is something that's to my liking. And yeah, then I made a decision to transition to robotics master. So I moved to Switzerland and studied at ETH Zurich. And yeah, really have been heavily involved in the robotics space ever since. And managed to been lucky to work with awesome robotics companies before. I think most notably a drone company here in Switzerland called Wingtra. Still one of the most incredible companies I know. Managed to work both on the autonomous flight stack over there. Later worked on some new products and a bit of a mixture of product and engineering. But yeah, I think that's a very short TLDR background and how I got into robotics.
That's awesome. That's awesome. So, Max, how has your educational background in robotics, as you mentioned in the ETH Zurich, influenced your approach to developing Loki, your current company?
So, I think it's as usual with background and with degrees and educational institutions that it is what you make of it the most, right? So I would say what we were super lucky with at ETH, A, there is amazing collective of professors. B, you can really study a variety of fields within robotics, right? As you know, robotics is many things. It's mechanical engineering, it's mechatronics, it's computer vision, it's controls engineering. So we really have the flexibility to really put our own curriculum together and based on what we're interested in and finding out a little bit more in detail. During ETH, I primarily took courses in controls and computer vision because these are the two topics that interested me the most. And of course, there's also a plethora of opportunities to basically put that knowledge in an applied setting, right? So Focus Projects is an amazing thing that ETH has, which is, again, these student teams building stuff from scratch. I already did one in Delft, not in ETH, but there's also opportunity for that to be doing that. And yeah, I guess just learning and understanding what robotics is about and what is really missing to fulfill on the promise of, okay, we're going to have millions of robots helping people around the world. We kind of gravitated towards Loki Robotics in the end because we feel like with robot learning and with new approaches of autonomy that really have been proven and appeared over the last couple of years, that promise might finally be here. So that's what really forced us to start taking, okay, let's build a robot that actually does useful stuff seriously. And yeah, I guess that was the very core and inception thought of when Loki came about, even before we were thinking about starting a company.
Awesome, awesome. You mentioned Wingtra, your previous company. It's quite different from what you're doing right now at Loki. Can you tell about your experience at Wingtra?
Yes. So first of all, incredible company. So what Wingtra does is they manufacture VTOL drones. So the way it works is takes off as a helicopter, transitions to a plane, and then takes a bunch of pictures from above, assembles them together in a map, and then this map is used for a variety of purposes, be it surveying, mapping, inspection across mining, construction industries, etc. And my experience there was incredible. As I said initially, I managed to work on the autonomous flight stack a little bit, and afterwards transitioned into working on some of the more newer products that basically try to make the workflow of, okay, we take a bunch of images with drones to we have an accurate map out of that, making that whole process smoother. Yeah, and I think it's they're doing well. It's an incredible company, and yeah, I had an awesome time over there.
Awesome, awesome. So getting back to Loki, Mix, what's the core mission of Loki Robotics, and how do you envision its impact in the industry you're working on?
Yeah, it's a great question. So the core mission at core, why we started Loki Robotics, and to be frank with you, why we got into robotics in the first place, is because we just think that human time is the most valuable capital we have as individuals, right? And we should strive as a humanity to do utmost best to free up as much of that important capital as we possibly can. And I think, I mean, even from the beginning of 20th century, like the idea of having a robot that helps around and do stuff that humans fundamentally don't like has been around, right? But of course, robotics is a complex subject with many different disciplines integrated into this one thing that need to be made work to fulfill that mission, right? Meaning that we need to build computer vision pipelines, we need to build controller stacks, we need to assemble that in functioning hardware. And that's very, very difficult to do, again, to do many, many things. And I think the exciting thing that has happened over the last couple of years, as I touched upon it earlier, is introduction to robot learning. This notion of we actually are able to train models end to end. So basically having sensory inputs, black box, and actuator outputs, and we can actually enable autonomy that way. Granted, we can collect many, many demonstrations at scale. And this is the exciting thing that I think is going to push us as a robotics industry further towards that promise of helping humans as much as we can with stuff that we don't like. And yeah, with Loki Robotics, we are really taking the crack at that. So we just want our mission to be save up as much of people's time as possible. I think the tangible and highest ambition that we have that we're trying to fulfill is eventually ship robots at home. So for in my home and yours, so they can assist us with tasks such as, of course, cleaning, but also, for an example, doing the laundry, emptying the dishwasher, etc. Right? So this is the most ambitious version of what we're doing and what we want to get to. Now, of course, to be able to get there, what do we need on the autonomy side, right? So first of all, to enable that autonomy, again, with robot learning, we need to collect data at scale, right? So how do we do that? And the second thing is we need to ensure that we can drive down the cost of hardware for it to be an affordable robot, right? I think at the current state of things, it is very difficult to assemble a robot and make a solid business case around it to be able to deploy it at home, which is, first of all, that's one of the reasons why we're going the commercial route first and actually building a commercial cleaning robot. And the second thing is for the data. We just believe that commercial applications and deploying our robots, for an example, in offices or in airports or similar environments, that actually enables us to already collect data at scale in in environments that are very similar to the household. So that's kind of the core thesis on what our approach to getting to that mission is. We start verticalized for a very specific use case in specific environments, collect data at scale over here whilst already enabling autonomy, and then progressively expanding the tasks over.
Awesome, awesome. So, Max, can you tell us a bit about the form factor right now of Loki Robotics? Right now, as we all know, humanoids are in the hot.
Yes.
But you chose another form factor. Can you tell us about that?
Exactly. I think the intuitive way how to think about our form factor and why we made that decision is we basically take the essential components of the humanoid robot that are required just to start doing the specific task that we're after, right? Which is cleaning restrooms. That's the first use case of our robot. So, and on top of that, we already know the environments that we need to be in. Most of the time, these are massive buildings with elevators, relatively flat surfaces. And as a result, for an example, do we need bipedal locomotion? Legs? Not necessarily. So we have wheels. Okay, do we need to have an independently actuated body, or can we just substitute that with a simpler version of, okay, a large vertical actuator carrying two robot arms? Yes, that's something that does fulfill our requirements. So effectively, how we're thinking about is how can we simplify the hardware problem as much as we can to build a platform that we can already deliver value to for that specific use case, which is cleaning. So this is how the form factor was incepted. So at the end of the day, it's a mobile platform on wheels with omnidirectional steering, a vertical actuator for a rail that basically mimics the human's ability to move up and down with our body without necessarily having an independently actuated body. And yes, two robot arms. Those are the basic components of the form factor.
Awesome, awesome. Can you also tell us, Mix, about the training process of your robots? You mentioned that it's end to end, but how do you actually collect the data?
Yes. So this is, I think, where the interesting part is, since we're in the all things like our podcast. So the main interface of the data collection pipeline is the VR headset. Now, we
Mm-hmm.
arrived at the VR headset and the VR controllers because through iterations we found out that VR is actually one of the most intuitive ways how we can mimic our emotions that we do as humans and transfer that to a robot, right? There were many iterations that we did. For an example, let's talk about depth perception, something that's super important for us to be able to place our cleaning end effector to a surface and track it accurately, right? Depth with a single camera on the screen really made it difficult for us to understand how exactly are we positioned in space? Do I need to move my robot arm 1 meter further in? Am I already touching the surface? That wasn't intuitive at all. So the next question for us was, okay, how do we enable depth perception to be able to understand the 3D position of the robot arm in space? Then for that, the answer was, okay, let's try the VR and the stereo camera setup. And that's what we found to work actually extremely effectively. And then we basically combined the VR headset with the VR controllers. And we've built our own custom software stack in a clever way, such that it's very intuitive for the robot arm to track the position of the end effector of the VR controller, right? So
Mm-hmm.
effectively what you're doing when you're collecting data with the VR headset is you're able to perceive depth. You have two independent VR controllers, each of them tracking each of the robot arm. So it's as if you're playing a game, a super realistic game of actually you being in that environment and cleaning that restroom. And yeah, we found it to work incredibly well. So we use the VR headset and the controllers as the main modality of interface. And then for the data collection pipeline, of course, we collect human demonstrations and then train our models with that.
So you're actually using VR teleportation for collecting data and training your models.
So VR teleoperation, the actual teleoperation component where there's a person and actually doing the work, it only happens at interference, right? So for an example, if there's a task the autonomous system is not able yet to solve, then the
Mm-hmm.
VR teleoperator steps in. Otherwise, it's happening autonomous. But the actual data collection, the pre-training part before deployment, this also happens within VR. And yeah, that's basically the data collection interface there.
Awesome. So, what are the next missions? What are the next projects you're excited about? What are the sectors that you think that Loki Robotics will be able to also step in?
Yeah, I think so. The first thing we're currently focusing on right now is being able to get to our first deployments. So this is going to be within office buildings and airports because that's one of the use cases where customers find most value in. And I think the next step from there is just to really gradually increase the scope of the tasks that we're doing, right? Because right now we are very focused, okay, let's deploy in a restroom in a single airport. Does that work? Great. Let's expand to multiple restrooms. Okay, now we're able to cover all the restrooms. What's next? Are we able to, for an example, go into an office building and start taking care of the tasks in the kitchen, wiping the sink, loading and unloading the dishwasher? So this progressive scope expansion is what we're going to do. And I find that an incredibly exciting journey to be on.
Yeah, yeah. So, as we know, there are also other types and kinds of training for robots. You have chosen a very interesting approach, but there may be other approaches that are more scalable. For example, teaching a robot to see a video of a human doing a task, or for example, doing word models as
Right.
the hype right now.
Yes.
What's your take on that?
So I guess my most important take that those are incredibly exciting directions. I really hope to see the day when it's just going to work and we'll have full scale world models that are able to represent reality accurately, or cross embodiment between human demonstrations and robots. Action space is going to be solved. As things stand right now, um, although I think there have been exciting developments in the last couple of weeks specifically, but as things stand right now, I think specifically for what we are doing, building an accurate world model or solving the cross embodiment problem from human demonstrations to robots is a very, very highly complex problem. Now, that's not to say that it can be solved, but we're just approaching the problem very pragmatically and asking, okay, which approach currently do we have the highest conviction in that we already know it works? And as a result, human demonstrations within the robot's embodiment is the answer to that. As a result, then the next step is just, okay, let's figure out how we can implement that into actual training, right? Which is where the VR came into, and then deploy these robots. So I guess they're definitely valid approaches. Just as of right now, where things stand, I think, yes, human demonstrations is the path that we find the most likely to succeed, and specifically for our use case. And yeah, as a result, that's what we're focusing on.
And you're actually collecting so much more data when you're training your robots on VR.
Yes, well, I guess depends on what you compare it with, right? And depends on the complexity of the task. I think the great thing about, for an example, being able to learn from human video demonstrations is that the video demonstration is a lot less intrusive, right? So we can imagine that that problem scales a lot better to, for specific our instance, if we are able to, I don't know, go to 20 different restrooms in a weekend and clean it ourselves with a GoPro attached, right? And if the cross embodiment issue would be solved, that would be a great approach. But yes, as I said, right now our conviction is purely based on human demonstrations in a robot embodiment, and yes, that's what we spend a lot of time on collecting data in.
Awesome. So, Max, can you tell us a bit about how adaptive Loki Robotics right now is to different environments, different surfaces, and different scenarios?
Yes. So that's definitely an open problem that we're still working on. Within the current test set that the robot has been deployed in, we are reaching pretty good levels of autonomy, I would say. But of course, all of these also have edge cases, right? Which is where the remote intervention comes into play. That being said, of course, we make sure to be able to train it, for an example, in different restrooms, right? Yes, every restroom does contain a sink, a tap, a mirror, a toilet seat, and then in half the restrooms we have urinals, right? So these are the basic elements that we have to be able to get right to make sure we can actually clean them. But of course, they come in different configurations where they are placed within the restroom, and of course, they also sometimes look different. So within our training set currently, we're able to perform the task very, very well. And again, we're continuously making efforts to expand that scope as well. So yeah, that's where we currently are.
Awesome. You mentioned mirrors. How do you solve that challenge?
Mirrors is a tricky thing for vision for sure. Luckily, the interesting thing is we are already collecting a lot of data prior to entering the restroom, such that we are actually able to identify, okay, this is a very highly likelihood area of where the mirror is, and hence the vision results that we get from that specific subset of the image should not be taken into account. Right now, it's a very pragmatic approach that we're taking it. And yeah, so far it seems to work.
Awesome. Awesome. And Mix, one thing that I think about what you're doing is really challenging. And one thing that I have never tried running a hardware startup is that
Yeah.
hardware is really, it's much harder than doing software alone. Can you tell us about challenges of running a hardware startup?
Yes, I think, Mateo, there's many, many, many. I guess so. The good thing is nowadays there is a variety of options available actually to take off the shelf components and experiment with. There's great manufacturers all across the world that are able to do that at very cost competitive prices for you to be able to just, I don't know, buy a cheap robot arm, see how it works, what are its limitations, does it have, are there any joint constraints that not satisfy your specific use case? Is it light enough? Is it powerful enough? All these things. That being said, I think, first of all, finding the right components is always, of course, a challenge and a pain to make sure they actually satisfy your requirements. Second thing, of course, the iteration cycle is longer, right? As a result, it's definitely harder to iterate on hardware iterations than it is for software because of many different tools that exist in software development ecosystem. But yeah, that being said, again, I guess this comes back from my previous experience and from my childhood days. The reward of working on physical things and seeing its impact in the physical world, to me personally, is exponentially more exciting than just writing software. And yeah, after all, that's why I just became a roboticist, I guess. But yeah, of course, in detail, there's many, many things we could talk about. Also on the distribution side, what are the challenges of hardware? Reliability is a big one, of course. But yeah, that being said, I think the excitement on working on in the physical world trumps all those challenges.
Yeah, surely. And makes a recent AI hype, we all see it, and over the past 2 years, there have been lots of progresses in AI. How did it affect you and your business and your approach to solving the problem you're trying to solve?
Yeah, I mean, it's a great question. I think the main thing is that actually, again, end to end learning through human demonstrations is very analogous to how we see large language models being trained for them to be so useful, right? So, in fact, I think specific showcases and research that have been done into, okay, how are we able to take a similar learning paradigm and use that for automation and robotics is very central to what inspired us to pursue Loki Robotics and build our automation pipeline this way. So it has had the most profound effect, if I can give you a very simple answer to that. And yeah, of course, that being said, I think there's challenges that still we need to solve. I think, again, we're figuring out a more effective and scalable way of how to collect demonstrations is definitely an exciting research avenue, which the smartest folks in the industry are working on. So yeah, we're just super excited to be part of the robotics community that yeah are trying to solve these things.
Awesome. We talked a bit about world models, and this is a fairly new thing. And we all saw the NVIDIA announcement at CES and their simulations that they provided. It is better. Is it better to train the model on actual real data or in simulation data? What's your take on that?
I think what's up with this really does depend on the use case a lot, right? Again, I
Hmm.
think cleaning robots and autonomous vehicles are probably two different enough domains to require independent thinking on both of them. That being said, for an example, the thing that we find particularly challenging for us for an example, to be able to train our models fully in the world model is object to object interactions, such that they physically represent the reality accurately, right? To give you an example, obviously we're working with deformable tools, cleaning tools that are actually the on top of the end effector that goes and wipes the surfaces. Are we always able to guarantee that the deformation of this tool across a variety of different surfaces that we may encounter in any bathroom that we enter, is that going to be represented accurately enough and closely enough to reality within the world model such that it's directly transferable, right? So at the high level, this is the abstracted problem of sim to real gap that is very famous in the robotic space. And again, for very specific things within our use case, we find that still to be a challenge. Again, that being said, I think with the rate of progress that world models are currently being developed with, I'm optimistic that this is going to be eventually solved.
Awesome, awesome. So it makes pushing local robotics further and doing more robots and entering new domains. What do you think about the challenges you'll be faced in scaling up a robotics startup?
Yeah, I think it always boils down to a couple of things, right? How do we minimize our expenses per unit? And so that being said, for us, this particularly is the expense on data collection and the expense on the cost of hardware itself. And yeah, I think these are the two central challenges of being able to scale, right? From a unit economics perspective. Of course, there's also the very pragmatic challenges. How do we assemble the robots? Where do we do it? Where is the most cost effective way of being able to do this? But yeah, all these questions are central to scaling. Now, that being said, I think the great thing is that minimizing the per unit costs with autonomy and with better engineering to make the same algorithms and autonomy set work with cheaper hardware, those are engineering challenges, right? At least that's the way we view them. So as a result, the bet here is, and I think that what most robotics companies focusing on is, okay, how are we able to put meaningful engineering hours such that the outcome of that is, okay, per unit cost is significantly lower, the degree of automation is significantly higher to drive per unit costs down for a single unit. And as a result, the product becomes a lot more scalable, right? So I think these are the two main challenges over there. And again, of course, the manufacturing is definitely a large problem set. Distribution is a large problem set. Maintenance is a large problem set, and all those things need to be thought about.
Awesome, awesome. So, talking a bit about business side of your startup mix. What's your current business model, and how do you manage that?
Yeah, so we deploy our robots basically with robots as a service model. So what this means is we actually go to the customer site, help them set it up, and also take care of the maintenance part for the customers, such that they basically receive a product that is supposed to do the job that was promised, which is in our case, helping commercial cleaning teams with their daily tasks. And we basically charge a fixed amount per month for that. And from the business side, how that looks like is, of course, this revenue accumulates and over time, and at some point you reach break even. And I think the important part of why we approach it this way instead of, for example, selling directly is very specific to our customer base, right? So our customer base are cleaning service providers, and oftentimes these are lower margin businesses that are not necessarily always able to allocate a large chunk of their margin immediately from their cash flow to just hire and get a robot up and running, right? So then we ask ourselves the question, how do we make sure that the adoption of our product is the easiest also from this perspective? And this monthly lease model is what we found to work the best.
So, for example, me as a customer don't actually have a cost on Loki Robotics. It's actually an investment.
Yes, so it would be an investment if you need to buy it up front, basically, yes. But instead, what we enable you to do is purchase our robot and its abilities to help you in your cleaning service provision exactly the same way as we would buy a software subscription. Yes.
So no additional cost on my side as a customer.
No additional cost on your side as a customer. We take care of the maintenance, we take care and help you resupply consumables, and if something happens, also to be there and either swap the unit out or help fix it on the site.
That's awesome. That's very clever. So, Mix, your background is in engineering. Can you tell us about your challenges on becoming a CEO and doing other stuff and going beyond an engineer and builder and managing a business?
Yeah, I mean, to be frank with you, I think it's a very natural progression. The most important thing that I've always just tried to do is learn as much as possible from the smartest people I know and are around me. I think this is a evergreen North Star to strive towards. I've been super privileged and lucky in my life to be able to be around such people. And as a result, be it from my studies in bachelor's to Formula Student to ETH to eventually at Wingtra and Loki, I have somehow always managed to be within these environments. And I think has helped me the most in developing as a person, as an engineer, as someone who needs to take up large scale projects and just make them work. And of course, that being said, I want to be very clear about this. Definitely by no means would consider myself an expert in that. I don't think I am the best engineer. I don't think I'm the best manager. I don't think I'm the best, a person who needs to manage this complex project. But again, it's all about making sure I have smart people around me that can help me to be better and improve from day to day. I think that's the best way I can describe it.
That's what the best people always say.
Well, I think it's very hard to define a metric. What does it mean to be the best, right? Again, of course, there is this North Star metric that everyone always is trying to strive towards. But that being said, I think if you look at it, the way we learn stuff as humans and accumulate knowledge, it's always is a function of a ton of people, and in some cases also infrastructure being there to help you and align for you such that you can just do your best job at learning and becoming better. So I guess that's what it's all about.
Mm-hmm. Awesome. So are there any book or other forms of content you recommend and have helped you along the way?
I think everything about this is a question. I think on the book side, I'm not such an avid reader for self-improvement. I read primarily books for entertainment. So maybe not on the book side, but I think what I have always found living in our day and age, I find this still incredible, that for almost any issue or problem, be it on a personal side, engineering side, management side, processes side, there will always be a YouTube video or there will always be some form of content online that is able to help you, from podcasts from folks like yourself, to really for you to be able to listen to that, evaluate what the other person is saying, and understand how applicable that is to my specific case or my problems that I'm currently solving. So I think in our day and age, the vastness of media and its diversity in terms of content and topic, it's incredible, right? So I think that's the media I consume the most to learn most every day.
Awesome. And how do you stay updated in your field?
Honestly, I think one great tool that has become incredible, I mean, I'm sure I'm not going to be at all the first person to say this, especially within the robotics community, Twitter has been amazing. There's a ton of amazing builders on Twitter who always post either what they're doing, what they're building. You can freely interact with them, ask questions, get to know them, meet up. I think this is incredible, right? So I think Twitter is primarily my main space and how I stay updated and what's happening. Yeah, typically if something big happens, everyone's talking about it, everyone's commenting, so it inevitably winds up on my timeline.
Yeah, me too. And Max, if someone is interested in pursuing a career in robotics, what steps would you recommend they take?
Great question. I think the two most important aspects is first having an ability to program and code. That would be a great start. As soon as you have that, order up a small test set of, I don't know, even do it in simulation. Try to do some TurtleBot simulations from Ross online first. Try to understand, okay, so robotics is not only about hardware, it's also about code, it's also about computer vision, path planning, controls, so many different things, right? And I think, yeah, just building personal projects is my way of learning. And I think most people would also agree that learning by doing is the most exciting and coolest, and at the end of the day, most valuable way of learning. So just personal projects as much as you can, any kind of robotics subfield or specific application you're interested in, just try to figure out what's the smallest minimum project that interests me that I should be able to complete and do, and just go for it. Again, there's so much content out there online for you to be able to learn and ask for help. I find it incredible. So I think it's yeah, my generation has been very privileged to be able to grow up and learn with that.
Yeah. So, are there any hardware starter kits you would recommend?
Yes, I think there is a few. I mean, one that particularly comes to mind is actually a robot arm that was built by a friend of ours as well, Alexander Koch. So he built a very small open source arm that basically consists of 3D printed parts and dynamics motors. And this is a great starter set to understand, okay, how does robot arm control actually look like? What do you need to be able to do to be able to manipulate it, right? And how do we go, let's say, from a simple pick and place to, I don't know, training a policy on such a robot arm? So I think that's a great resource. And I think that arm was actually adopted by Hugging Face in their Little Robot project. And I think they have great starter content for that. I think so. That would be, I guess, the first place I would start at if I was to start at right now.
Awesome. And in your view, what's the most exciting aspect of working in robotics today? And what are the most exciting projects in robotics right now?
Great question. I think my answer to what makes robotics exciting is pretty time invariant. So, what I mean by that, again, going back to what we talked about initially, just the promise of being able to affect the real world with something that you've programmed and built, I find that still magical and absolutely incredible. And so, I guess that would still be my answer. Of course, robot-based learning and enabling autonomy that way is incredibly exciting because it opens up so much more use cases. Decreasing cost of hardware, better and better manufacturers for that is also really, really cool. So I think that's the main why of find robotics exciting right now. And in terms of who's more exciting, I mean, there's tons of companies out there, right? From the learning side, I mean, Physical Intelligence, incredible company and what they're doing and trying to build foundation models for robotics. Then from specifically verticalized or applied robotics companies specifically. Again, I'm very biased. I will still say Wingtra is probably one of my top favorite robotics company. From some of the other more internationally known ones in the US, perhaps the Butt Company, Cobot. I find them what they're working on incredibly exciting, and of course, humanoid companies, 1X, Tesla, Figure. All of those are incredible inspiration as well to just let's get this to work and let's get it done mentality. So yeah, I guess for the specific names I could mention, those will be the top of my mind. But again, I think it's an endless list of exciting companies.
Awesome. And next, how can our listeners learn more about Loki Robotics and yourself and get involved with your company?
Yes, so definitely, I think the first touch point is go to our website, lokirobotics.co. So not .com, .co, so .co.
Mm-hmm.
You can also find us on Twitter with my first name, last name, or my co-founder, Antonio Arbuez. Yeah, we're always open to chat, always open to have discussions with folks who would like to get in touch. So yeah, I think those are the two best methods of communication.
Awesome. We'll surely put links on the description of the podcast. And Max, as our for the last question, how do you envision a future where we live alongside with all kinds of various robots in our daily lives?
That's an amazing question that we really think about on a daily basis. I think I think the most exciting part is, again, asking yourself the question, what happens if physical labor becomes free? How much more we as a humanity are able to achieve from a technological progress perspective, from removing people from hard positions of reliance on hard menial physical labor to do these tasks and enabling other opportunities for them. I think, again, if you ask me what's the most inspiring, ambitious vision that you could work towards and try to make that your life work, I would say it's that. And that's precisely why we're building Loki Robotics and why we want to be a part of that.
And you said about free labor, and also people talk about post AGI economy. What's your take on that, Mix?
I mean, the two, in my opinion, I will discuss specifically on the physical aspect, on the aspect of physical labor and its influence in that. I think the two most important questions to be solved here is, okay, how do we make sure we can free up as much of people's time as possible, and such that people do not need to do this kind of work anymore, that fundamentally almost no people want to do it. And the second thing is, okay, what happens then, right, with the people who have currently been doing these kinds of work? And I think the two
Exactly.
crucial pieces to solve here is, okay, how do we make education as freely accessible and available to everyone, such that we are able to reskill and reallocate ourselves amongst different subsegments of the economy. And of course, then the second question is, okay, once we are able to do that, who is going to do this physical work? And I guess the latter is what we are focusing on, Loki Robotics, and what we want to be part of.
Awesome, awesome. Well, thanks, Mix. It was great having you on the All Things Success podcast. Thanks very much.
My Todd, thanks for having me. It was an amazing conversation, and yeah, thanks for the opportunity.
Thanks very much.